So we are moving right for next question. Next question we have is this is the question here. If X is the ratio of rotational kinetic energy and translated kinetic energy of rolling body, then the following is true. So the following is true. So this is the ratio of kinetic energy and translational kinetic energy. Rotational kinetic energy is to translational kinetic energy. Basically, if I ask you what is rotational kinetic energy, can anyone explain it? So rotational kinetic energy is half I omega square. Am I right? Half I omega square. It is rotational kinetic energy. If I'm talking about translational kinetic energy, this is nothing weird but half and this square. Am I right? So yeah, so using this concept, I'm going to perform this questions. So the ratio, x ratio, rotational by rotational divided by translational is always less than equals to 1. Always less than equals to 1. Next question we are moving ahead. Solid sphere, solid cylinder, hollow sphere, and hollow cylinders are simultaneously start rolling down from the top of a inclined plane. If A is acceleration of the center of mass, then A is. Basically, you should know the formula that is acceleration. This following rolling top of inclined plane. So yeah, the acceleration is equal to using the form use this formula G sine theta, G sine theta divided by 1 plus I divided by mr square. mr square. Basically, I is what moment of inertia. So if moment of inertia is high, so acceleration is low. And if momentum of inertia is low, so acceleration is high. If I talk about the moment of inertia of solid sphere, the moment of inertia of solid sphere is 2 by 5 mr square. The 2 by 5 mr square. That is, I think, least among all. So we can check once 0.4 mr square. So for solid sphere, moment acceleration should be high. Using this concept, I'm solving these questions. So maximum for solid cylinder, this. So maximum for solid sphere, maximum for hollow sphere. Okay. So this way we can solve this question. This is no issue. Next question, I'm moving ahead. In our problem, if we use the time to reach the bottom of the inclined plane, then so obviously, if I will ask you, acceleration is high, acceleration is more, so time will be less. Time will be less. If acceleration less, time will be more. So basically, the relation between acceleration and time is opposite, inverse. So yeah. So if you see the options, so minimum for solid sphere, obviously, and minimum for solid sphere because acceleration is maximum for solid sphere. So you can solve this question easily. Next question we have a body is rolling or on inclined plane of which angle of inclination is theta. If is acceleration at center of mass, then column is a correct. Rolling law. So this is not normal case. This is rolling case. In a rolling, acceleration is always less than g sine theta. So you need to take care of your brain that in rolling, yeah, normally if nothing happening, okay, suppose translation happening. So there we can say acceleration is what g sine theta. Translation in motions, but in rolling, acceleration is always less than g sine theta. So you should know this relation as well. So now we perform questions based on angular momentum and rolling motions. So we have a questions below the dancer. The dancer is rotating about his own vertical axis on its most horizontal floor. I omega L and E are momentum inertia, angular velocity, angular momentum, rotational kinetic energy of below dancer. Respectively, below dancer stretches himself away from his axis of rotation, then the following choice is choose. Basically, see, if a dancer will stretch herself, so basically what will happen? Moment of inertia will increase because of this distancing. I already explained the concept of distancing. If you don't know, so your teacher will explain in your classroom that what is the concept of distancing and angular momentum is always constant, that is I into omega is constant. If I is more, so angular momentum will be less. This concept, using this concept, we can solve these questions. So correct answer for this question will be I increases and omega E decreases, but L is constant. So omega is angular momentum, angular velocity. So angular velocity, as angular velocity is decreasing, so obviously rotational kinetic energy is half I omega square, half I omega square. So rotational kinetic energy will also decrease. So this way we can solve this questions easily. It's easy questions, we can solve it. Okay, so now we are moving for next question. If a polar ice caps melts, then the time duration of 1 day, okay, increases. So basically, what happened if polar ice cap melts, it will come to equator. So decreases does not change, so increases. Okay, so why? Okay, because if I'll ask you, suppose if I ask you what is time period, so time period of 2 pi I by md. If you suppose if you use this relation 2 pi I by md, so basically what's happened, if you are using this concept, so time period if I will increase, so you can say time period will increase. Okay, so you can solve this question other ways as well, and give you the one idea for this question. A hollow sphere partly filled with water has moment of inertia I when it is rotated about its own axis, and angular moment of omega is, if it's on angular speed is double, then its moment of increases because increases moment of inertia becomes. Okay, so obviously angular momentum is conserved again, and I omega is constant. Okay, again the omega is double, so moment of so if its angular velocity is double, angular velocity is double. Okay, so when it is rotating with the axis at an angular speed omega, its angular on velocity is double, which on angular speed, then moment of inertia becomes. Okay, so if you are conserving the angular momentum, if you're conserving the angular momentum, so what will be correct answer for this? Okay, so its moment of inertia becomes. Okay, so if its on angular velocity is double of hollow sphere partially. So basically, what is happening here? This sphere is partially filled with water. If omega is increasing, so water will come here. Water will come here because it's partially filled. It's partially filled. That's why distancing. Again, if you apply the concept of distancing, omega will increase. Omega will increase means water drops comes here, and that's why because of distancing, angular momentum is 7 increase. Next question I have: if most of the population on Earth is migrated towards the Earth, then the time duration of the day. So again, it's an easy question. You can do the time duration of the day will decrease. I already told you the concept. Okay, because again you could use the concept of moment of inertia because most of the mass is here distancing. So you rotate about this axis, distancing it. This all mass will shift here. So what will happen? Moment of inertia will reduce. The time period will reduce. So use this concept to solve this question. So the other way, you can solve it. You also need this solve like this. You can follow other way as well. Next question I have the law of conservation of angular moment is obtained from the Newton's second law in rotational motion when it's easy questions. External torque is zero. Like external torque is zero. Next question I have circular disc is rotating in a horizontal plane about vertical axis passing through its center without friction. If the person standing on the disc is it, if the person gently walks to the center of this disc, then it's angular velocity. Again, the same concept you are using, move towards the center, and if you are moving towards the center, moment of inertia will decrease and all those things. So basically, moment of inertia will decrease, then angular velocity will increase. Again, you can do this question by conservation of angular momentum. We are moving for next questions. A balloon Dancer rotating about its own vertical axis without external torque, which angular velocity is double the its rotational kinetic energy. Again, this is very easy question. So obviously, okay, rotational kinetic energy. Question is talking about rotational kinetic energy. So basically, what is happening? Some students do like this, that rotational kinetic half omega. That's why. So if double omega is double, so it's happening like 4 times, not like that because angular I will also change. Okay. External torque is angular velocity is double, then it's rotational kinetic energy. You to conserve. So how you will find out first? I you will find out by conserving L, and then you can find out this. You will get the answer double. Okay, so it's a good question. It's a very good question. It's very good question. Okay, you know the concept. Then only solve this because otherwise this question is difficult for you to do. Okay, if you can't remember directly the result, it's not. I will not suggest you to remember the result directly. The next question I'm moving ahead. So a driver found himself close to the axis of rotation while driving down. Okay. So a driver found himself close to the axis of rotation while driving down. Why this again the concept is same. So this the rotational kinetic energy of downside increases, angular momentum of driver remains constant. What's the correct answer? And below to angular momentum driver remains constant and rotational kinetic energy of downside increases. Rotational kinetic energy of downside increases. Next question I'm moving at B is the velocity of center of mass of a rolling body, then velocity of topmost quantities. Again, this is very good question. This is very good. At rolling, this B is equals to what? B is equals to what? B is equals to here B is equals to omega into R. And here this is what B plus omega R. This is, and what is the speed here? Center of mass speed is B. This is very good question. This is stationary. This is stationary. Okay. This is stationary. So if you see, okay, and so B equals to omega R, B equals to omega R, B equals to omega R, so B plus omega R, B. So you can say this is what 2B things like this. So now you can solve this question easily. So So what is the correct answer? So velocity of the topmost point is 2v and velocity of the topmost point is 0. Velocity of the topmost point is 0. This is bottommost, okay? This is what? So that was bottommost point, okay? What I'm trying to tell you, see here. Uh, this velocity of this is, I already explained this concept. So this is actually not topmost, this is bottom. Okay, bottom. The velocity of bottommost is 0. Agree? Yeah. So next, I'm moving ahead. Next question is an inextensible light string is wound over the flying wheel and the body is suspended at over end of the string. The acceleration of suspended body when it is released is independent of the mass of suspended body, mass of wheel, radius of wheel. So answer is radius of wheel. This question is easy. You will read the question, you will understand it. A particular mass having working along the circular path of radius are similar speed. Momentum is L. The centripetal force acting on the particle is centripetal force acting on the particle is. This question is easy, but you can do it. That is L square by MRQ. So you can remember these questions also, this formula also, that if a particular mass M is working along a circular path of radius R and its angular momentum is L, then centripetal force is acting on the particle is L square by MRQ. L square by MRQ. L square by MRQ. So next question I'm moving ahead is force vector is along x-axis, radius vector is along y-axis, then the direction of torque is along. I already discussed over do this question easily. It's an easy question now. Okay, if you know the concept, you can do it. Okay, next question I am moving. A particular mass M moving along a circle of radius r with the time period of the angular momentum. Again, this is easy question, doable question. So basically, what's happening? So if you know the basic question, what is angular momentum? M and what is B? B is M into what is B? 2 pi r by t. Am I right? If you solve it, so what's coming to pi r square by t into m. So this concept is a very good question. This is a good question. I will tell you this is a good question. Okay. Next question I'm moving ahead. Motion based on motion is vertical circle. A car is moving up with a uniform speed along a flyover bridge, which is part of vertical circle. To follow this through. So this. So question is talking about the car is moving up, moving up. Okay, uniform speed, moving up. Normal reaction of the car gradually this is to becomes minimum at highest position of the base. Okay, so why? Because not at maximum point. If you go to the maximum point, n will be balanced, n. So the normal will be upward and mg will be downward. Yes or no? Normal will be upward and mg will be downward. Yes or no? Because if you see highest point. So what's happening? Centrifugal force will be what? Centrifugal force will be outwards. Yes or no? Centrifugal force will be outwards. So if you move here, so what will happen? What will happen? Normal plus centrifugal force will balance mg. Do you agree? So normal reaction of the car gradually cease becomes minimum at highest position of the base. Minimum at highest position of the base. So yeah, next question. This is very good question. So you can think on this. You can think on this path. Okay, if the car is here, what will happen? If the car is here, what will happen? If the car is here, normally is again upwards, and mg is downwards, and this one, what? Centrifugal force will be again here, downwards here. Okay, but what's happening here? Normal is outward, centrifugal force is outward, mg is only downwards. That's why. So yeah, next question. I'm moving ahead. A bottle of soda water is rotated in a vertical circular circle with the neck held in hand. The air bubbles are collected near the neck. This is easy question. Anyone does near the neck. Air bubble collected are near the neck. You have seen this question. Seen this experiment as well. Okay. So during roadside, you will observe this. Yeah, the vehicle is moving with uniform speed along horizontal, concave, and convex surface roads. Okay, concave. So basically, what is I'm talking about? This is concave surface. This is convex surface. Okay. This is concave surface. This is convex surface roads. Normal reaction on the maximum at the following surface. So I already explained you that normal here, normal, this is normal, here is normal, and this is centrifugal is here. The centrifugal will be here, and what? Centrifugal will be here, and mg will be here. Okay, if you're talking about. And here, what will happen? Centrifugal force will be outward, centrifugal force will sit in the car, centrifugal force will outward, and what? Normal will be also again outwards, and this will be mg. This will be mg. So, question is normal reactions on the maximum at the following surface. So normal reaction will be maximum here. So you frame the equations. What is the answer coming? Okay, so if you see the normal is coming here on concave surface maximum. Why? Because here normal is sum of centrifugal force plus of mg. But what is happening here? Normal plus centrifugal force equal to mg. So what is happening? Normal is what? Mg minus of centrifugal force. So that's why here normal is less. On convex surface, normal will be less. So that's why it's going out of the position. That's why it's going out of the road or out of the position. Yeah. The next question I'm moving ahead. We have a next question. Are in solid sphere and this different masses rotated with the same kinetic energy? Equal torques are applied on top of them. The body which makes the least number of rotates before coming to rest is. So basically, question is talking about the body which makes the least number of rotations. Okay, least number of rotations. Okay, before coming to rest. Okay, you tell me if the acceleration is less, it will come. If acceleration is less, if acceleration less, and acceleration is more. So what will happen? If acceleration is more, so what will happen? If acceleration less, what will happen? Thing like this. Okay, so what is the options we have? So correct answer, all will make same number of rotations. All will make same number of rotations because why? Because see, if you cut it, okay, these two different masses will be the same line equal to. Basically, this is radius is same over here. All have radius same. If you cover distance, what do you know? You 2 pi r one revolution, you will be going to cover 2 pi r. So if L is the length, L by 2 pi r. Number of revolution is required not to come before rest on the bottom. It's good questions, for confusing questions. Okay. So if you apply simple brain, you can solve it. If you apply too much brain here for solving these questions, you may get confused. Okay. Next question, we have to body with moment of inertia. I1, I2, I1 is greater than have equal momentum. Kinetic and rotations are even equal then. Kinetic and rotation even equal angular momentum. So equal angular momentum. Okay, equal angular momentum. So kinetic energy what half I omega square, I omega is constant. Whatever this equal angular momentum, kinetic and rotation you need. I omega is if you take I omega constant, so I because I1 is greater than I2, so you can say omega 1 is less than omega 2. Thing like this. So basically, what will happen? E1 will be less than E2. E1 will be less than E2. Kinetic energy of rotation of E1, E2. E1 will be less than E2. Next question, I'm moving right away. The torque acting upon system is zero. So the following will be constant. Torque is constant. Angular momentum will be conserved. Torque is constant. Torque is zero. Angular momentum will be conserved. Next question, I'm moving ahead. A dancer on ice spins faster when she holds her arms. This is I already explained this question. This is why because of constant angular momentum and increasing kinetic energy. And a man is sitting on a rotating table with his arms stretched outward with the suddenly folds his arms inside. Then what will happen? I already explained again this question. What is the moment of inertia decreases? Solid iron sphere A, the solid sphere A rolls down on an inclined plane while an identical sphere B slides down the plane in a frictionless manner. At the bottom of the inclined plane, the total kinetic energy of the sphere A is. At the bottom, the total kinetic energy of the sphere A is a solid iron sphere. A rolls down on an inclined plane while an identical sphere B slides down the plane in a frictionless manner. Iron sphere A rolls down an inclined plane while an identical sphere B slides down the plane in a frictionless manner. So at the bottom of the inclined plane, the total kinetic energy of sphere A is. So basically in surface B, there is no frictions. Okay, so what's the answer? So equal to that of B. So total kinetic energy of the sphere. The total kinetic energy of the sphere identical sphere B slide down plane in a frictionless total kinetic energy will be identical. Next question. So thin uniform circular ring is rolling down an inclined plane of inclination 30 degrees without slipping. Its linear acceleration along the inclined plane will be. I already explained you a ring. This uniform circular ring is rolling. So acceleration is what? G sine theta divided by 1 plus I by mr square ring. For ring I is mr square cancel out. This is 1 plus 1. So G sine theta is what? Sine 30 degree. Sine 30 degree divided by 1 plus 1, 2. So now you can solve this. You can solve it, you will get the options. So what is correct answer? So correct answer is G4. Next questions I have a body of mass M slides down or inclined plane reaches the bottom with a velocity V. If the same mass were in the form of a ring which rolls down in inclination, velocity varying the bottom of the abdomen. See body of mass is rotating speed will. So what is the speed of ring? Question asking. So that will be v by root 2. V by root 2. Next, I'm moving it. A circular wheel is rotating in a horizontal plane without friction about its axis. If a body is gently attached to the rim of the wheel, then the which following is false. Easy question. So you can do it if you know the question. You can solve this question. Angular momentum increases, but angular velocity remains same. Okay, angular momentum increases. A circular wheel is rotating in horizontal plane without friction, no friction. Okay, about it, if a body gently attached, gently is written. Okay, so to the rim of the wheel. So if you attach the okay, if you attach the body, what will happen? Angular momentum increase gently. Okay, you are putting gently, and angular velocity remains the same. So next question I'm moving ahead is solid sphere, hollow sphere. This are starting rolling the protocol and the body is at longest step. Longest step is acceleration less, so that is hollow cylinder. Next question I'm moving at solid sphere is this. So acceleration of the body is max. So I already did this questions. Correct answer is solid sphere. Next questions we are in case of following rolling bodies, translating rotational kinetic energies are equal. So translating kinetic energies are equal for circular ring. This the correct answer. Circular ring. So for circular ring, translational and kinetic energy are equal. So basically, what all of you know, translational kinetic is half mv square. This is rotational kinetic energy half I omega square, and omega is basically what 1/2 I omega is what v by okay v equals to omega r. So you can say v by r is omega here. You can say solve put here v by r square, then you can compare, it will come same. If after solving this for circular ring, if you solve this, it will come half mv square. So that's why I'm saying it's equal to translational kinetic energy. Next questions, I have simple pendulum is suspended from the fixed point, and m is the mass of the bob. When the bob is at the lowest position, the bob is given a minimum velocity in horizontal direction, so that the bob describes vertical circle. So when the string is horizontal, the tension in it is okay. So basically this and this string goes like this. Okay, it goes like this. Okay, suppose we're talking about the when the bob describes the string is horizontal. So basically, what will happen? mv square by r will be outward, and this will be equal to tension simply. Okay, because mg will be downward here. Okay, so it's already I have okay. Your teacher may taught you this concept. Okay, so this is easy question. We will solve it. So what's the correct answer? Correct answer 3 mg. So it means at bottom, what is going to be at bottom? It is going to be 6 mg. At bottom, it's going to be 6 mg, and then here 3 mg, and here you can say 0. 10. You can say 0, just 0. It's easy question, dual question. You can solve the equation. You can do this question, but this is good questions. Okay, it's a good question. So if you know the concept, then you can solve this question. Otherwise, it's difficult for you to solve this question. Next question, I have body of mass and moving circular radius are with the constant speed, the force on the body. I'm just directed towards the center. The work done by the force in moving body over half the circumference, over the half the circumference of the circle. The question is talking about work done. So what is called that also work done? So here, what displacement is perpendicular to force. Am I right? So work done will be 0. So this is very famous questions you should know. Next questions I am doing a body is tied at the end of the string of length L and involved in a vertical circle. The string is just the top. When the top and when the body is at the highest position, velocity of the body when the string is in horizontal. Tied at the end of the string of length L involving vertical circle. Vertical circular motion. Question talking about the string is velocity of the body when the string is horizontal. Velocity of the body when the string is horizontal. It's very easy questions. So very easy question like this. This string like this. And this is so here the speed will be what? Okay, 5 GL. Here speed will be root 3 GL. And here speed will be root GL for completing the circular motion. So for completing circular motion, these conditions should be followed out. You can see the options and you can correct the answers. Yeah. Next question I'm moving at a body of mass M. The mass having rotated in a vertical circle with the help of dot strings such that velocity of body at a point is equal to the critical velocity at the point. If T1, T2 the tension in the string when the body is crossing the highest and the lowest point of the vertical circle respectively, then the following relations I already taught you right now. So it's very easy questions and very good questions. Yeah, one more thing, T1 will be greater than T2. If T1 is the bottom, okay, you can see the questions once again. Body at a point equal to critical velocity T1, T2 the tension resting when the body is crossing the highest and the lowest point. Okay, here is it is opposite, means lowest point is T2. So T2 will be greater than T1. Okay. So basically T2 minus T1. Okay. And only taught you at the bottom what is tension 6 mg. You can find out by solving questions easily. This relation is easy, but better to remember this result. It will be easy for you. Okay, so correct answer will be first. Next question, I'm moving right. A body of mass emily rotated in a vertical circular radius r by means of a light string. If the velocity of the body is root g r while it is crossing highest point of vertical circle, then in the string is okay vertical circle. Then okay, so basically I messed up the questions. Okay, so basically I'm talking about tension. Tension in the string is okay. I'm talking about tension. So okay, so the tension in the string will be zero at the endpoint. Next question, I'm moving ahead. A small bucket containing water is rotated in a vertical circular radius r by means of rope. If the velocity of bucket at highest point, then the water does not fall down. If velocity again we did this question, yes or no? So your velocity should be what? If your velocity should be what? At the bottom, what was the velocity? Root gr. So if you maintain the speed with more than root gr, so water will not fall. Water will not fall, and you can do this experiment with your hand and itself. Okay, this experiment I had done many times. Okay, during bath, you can do this experiment. Try to rotate your bucket. Even you can take a smaller container and take full of water and try to increase the speed. Okay, increase the speed. So water will not fall even on the vertical position. It's very good, interesting. Okay, if you know, then you will do it. Yeah. So next question, I'm moving ahead. Next question, I have an army vehicle. Army vehicle is traveling at uniform speed along convex road. So convex road, this is convex road, and then along the and then along concave road of same radius of curvature. Then along the okay. So along the and finally along horizontal road. So see, I'm making the figure in the order. So first one is convex, then concave, and then horizontal. Normal reaction on the vehicle while crossing highest point of the convex road, lowest point of the concave road, and horizontal. You see here basically normal is what mg. Simply here normal is what mg. I already told you here. Okay, normal will be what less. Here normal will be less. Okay, and here normal will be greater than mg. I already taught you. Okay, so now you can arrange the order. It's very good questions. Now you can arrange the order. What will be the correct answer? So obviously R2 will be R2 will be more than R3, then R1 will be less. R1 will be less. Okay. Yeah. Next questions. I'm moving ahead. These questions I have done. Next questions. We'll do questions based on work, power, and rolling motion, and rotational kinetic energy. Yeah. The next question, I have the velocity center of mass of a rolling body is V, then the velocity of highest point of the that point is velocity of center of mass of a rolling body is V. So question is talking about rolling body V, then the velocity. I already did this question right now. Okay, so what is the correct answer? 2B. Okay, 2B. I already explained this question right now, so you can do this question. You should know the rolling concept. If V is the velocity center of mass of the rolling body, then the velocity will lowest one. I already again this explained already this question 0. Next question I have a wheel of plate RE3 to rotate about its own axis. The conditional force have to be applied on the wheel along with its rim. Its rim. If theta is the angular displacement of the wheel due to the force have, then work done is again, I have done the discussion. You have to remember this formula RF theta. RF theta. So work done is what? So basically what? F and displacement R theta, RD theta, and displacement RD theta, and F into RD theta. So displacement RD theta is theta equals to L by R. You know theta equal to L by R. So from here I'm talking L is what RD theta, R theta. So F R theta. It's a very good question, famous question. Okay, so you should know these questions. Okay. So yeah, if you know these questions, you can do this concept easily. Otherwise, very difficult to understand the questions. Yeah. Now I'm moving ahead for next questions. I have is an electric motor rotates in the wheel at a constant angular speed of omega while opposing torque is tau. The power of that electric motor is. The question is talking about the power of electric motor is tau omega. Tau omega. For power of the electric motor is tau omega. See, you know now in okay analogy. Power is what F into B. F into B. On the same way here, power is what F is tau. B is omega. So tau into omega. It's very good question. You can say F dot V here on the same way you can say tau dot omega. No, okay. So I'm moving it for next question. The angular momentum to rotating bodies are equal if the ratio of their moment of inertia is 1:4. The ratio their rotational kinetic energy is. So you can solve this question. You will get the answer for this one. Next question, I'm moving at the ratio of rotational kinetic energy translates the kinetic energy in a rolling circle disc is. Again, you will solve. I already explained this concept. 1:2. It will become 1:2. Next question, I'm moving at simple pendulum of length L is set into motion such that the bomb moves along a horizontal circle path and resting makes a constant angle with the vertical. If T is the time period, then the tension in the string T is. So already it's, you should know this concept. Okay, it's basically fundamental. So correct answer comes here is these options we have. So option A and C are correct here. So basically, if you see, so T is proportional to T power minus 2 and T is proportional to length as well. You know this person, you can do this person. Otherwise, it's very difficult for you to do this person. So, yeah, next person, I'm moving on. Okay. Next question is, I have a momentum of inertia of a rigid body depends on mass of the body, position of the axis of rotation, angular velocity of the body, time period of this rotation. So which one is correct answer? The correct answer A and B are correct. So mass of the body. So basically, momentum of inertia, moment of inertia of a body depends on mass of the and position of the. I already explained this question, no? Yeah. So yeah, I'm moving ahead now. Yeah, I'm moving ahead now. So next question we have is these questions we have. So Earth in this rotates about an axis passing through the center and perpendicular to the plane with the constant angular velocity omega. I is the momentum inertia of the disk, L is the angular momentum about the given axis, then the total rotational kinetic energy of the disk is. Question talking about rotational kinetic energy. Question talking about rotational kinetic energy. So what is the correct answer for each easy question you can do it? So rotational kinetic energy A and D are correct. E is proportional L square, E is proportional I power minus 1. So this is easy questions you can do it. Okay, so yeah, I'm moving ahead for next questions. So next question, so I have a particle moves along a horizontal circle with a constant speed. If A is the acceleration and E is its kinetic energy, so A is constant. So particle moves along a horizontal circle with a constant speed. Okay, the constant particle moving with a constant speed. So obviously, if the particle is moving with a constant speed, so its kinetic energy will be constant. Kinetic energy will be constant, and with constant if the A is acceleration and E is its kinetic energy. Okay, moving with along a vertical horizontal circle with constant speed, it age accelerations. Acceleration will be what? Because it's moving on a horizontal circle, so acceleration. A horizontal circle, so acceleration will be towards the center, no unit. So here energy will be constant, no unit, and acceleration variable because acceleration is changing each time. Acceleration is changing each time. So it's good. It's basically circular motion. Cause circular motion. We are talking about horizontal circular motions. Next process I have is this one. So match, we have to match list match angular momentum and all rotational kinetic solid square this. You need to find out that basically the very easy questions. I'm giving the options. So what's the correct answer for this? If you see for I'm talking moment of inertia, so moment of inertia is basically what MR is for you already know. I'm talking about torque. The torque is what? Okay, this is what R cross F. You already know. Next I'm talking angular momentum. Angular momentum is what? Okay, so angular momentum I'm talking about. They here I had given you the dimensions. You can find out. Notice the kinetic is solid square half I omega square. You can do. So each questions, if you know the question, you can solve the all questions of it.